So on the pre-course assessment, the average was 8.75 right out of 30. And over the past several years, the average has been 8.43. So right there, slightly above the average. Median was 8, and that's also the historical average. And it ranged from 4 right at the least and 27 right for the most. But it's a typical class. Congratulations. Definitely not expecting those scores at the end of the semester. So not with, are there any questions? All right. The last thing that we did on Thursday. Thursday?
No, it's an extra notes. I have, but the last thing we did was the vocab. Speed, or like vector, scale.
Okay.
For.
We got to velocity, we did not get to, we got to acceleration? Got to acceleration, okay. So what is position?
Relative to the origin?
Yes. If you have whatever memory trick you come up with, displacement and position, not the same thing. Position with respect to the origin, think of origin O, position P, you've got PO for post office or Pacific Ocean, OP for Ocean Pacific, OP from Andy Griffith Show. So this is with respect to origin. All right, so let's just do a quick little exercise here. I'm going to establish that as my origin. I will just, out of habit, make to the right positive. So it's a one-dimensional problem, so we can get away with identifying whether something is positive or negative or zero based upon just a plus or minus. We don't need a unit vector if it's a one-dimensional problem. So if that's my origin, is my position positive, negative, or zero?
Positive.
All right. And now?
Negative.
Or no, you're going
Why
back
don't you
to
just
the
walk-
zero.
Origin's right here. And I know there might be a slight parallax there, but just sort of go with the spirit of, I'm at the origin. What is my position?
0.
And my position now?
Negative.
All right, this is the way the game is played. Position,
Positive.
position.
Negative.
All right, we're on a roll. Displacement. What is displacement?
Where an object is with respect to the starting point.
Okay. Now, what's considered the starting point depends upon the frame of mind that you're in, but typically, we're talking about the overall displacement as a default, and so the starting point is the beginning of the problem, not the beginning of that moment that you're really in. So for the sake of this, I'm going to consider this to be my starting point. I don't need to redefine the positive direction because I've done it once and that's all I need to do. So right now, let me start here. My position,
0.
Zero.
It's just the starting point. It's just the starting point.
what's my position?
Positive.
There we go. Starting point relative to 0. What's my displacement? Now's the chance to bring in that one.
0.
Yeah, 0. My position,
Positive.
my displacement,
Positive.
okay. My position,
Negative.
No, it's not positive.
Positive.
it's one of those two.
It's negative,
Why negative?
because you've moved left.
Position, origin. Am I on the positive or negative side of the origin?
Oh, positive.
Yeah, and my displacement?
Negative.
Yeah, you were just ahead of your time. My displacement,
Negative.
my position,
Zero.
displacement,
Negative.
position,
Negative.
all right. Questions at this point, because we're gonna add another aspect to it. All right, let's do the next one. So in terms of X, Y, Z, R, S, whatever letter you're using, this is delta. And now velocity. So it's either dealing with the change in position over time, change in position over change in time, or displacement over change in time. Default is instantaneous, and so probably the better definition for what we're doing right here is velocity is how fast and in what direction. Is object going. All that time in elementary school is spent learning to write like this, but most of my time is spent writing like this. My velocity?
Positive.
Why?
Because you're moving. Because if you had a negative velocity, you wouldn't be moving. Or well, you could be going. Depends on what you're moving across. Yeah.
Okay, that seemed all over the place, but let's see if we can narrow that down some. All right, so since velocity cares about the direction I'm going in, what's my velocity now? Which is positive or negative?
Negative.
Okay. And my velocity now? Okay. So if I care about velocity, instantaneous by default, if I care about the velocity, I care about which direction I'm moving in. So we're gonna have to get a little bit faster because I've got three things now we're working with. Ready? Position,
Positive.
displacement,
Positive.
velocity.
Zero.
All right, that was too easy. My velocity,
Negative.
displacement,
Negative.
Position.
Positive.
Yeah, that was the intent. All right. Velocity,
Positive.
position,
Negative.
displacement,
Negative.
displacement,
Negative.
velocity,
Negative.
position,
Positive.
velocity,
Positive.
displacement.
Negative.
All right. Relatively simple. In a panic moment, you might blank, but the next one. This is where it gets a little bit trickier. Oh, actually, before we do acceleration, just do one more of that, one more of these other ones. My velocity,
Negative.
my speed,
What? Huh? You're looking about 2 miles an hour.
positive, negative, or zero.
Oh, positive.
Yeah, speed's always positive. Or it's non-zero, I should say. Speed can't be zero. Acceleration. Now, the direction of acceleration well, mathematically, it's the change in the velocity over the change in time. So if my velocity changes for the positive, if it's a positive change, acceleration is positive. If it's a negative change, acceleration is negative. That seems simple. So let's just try this one. So I start out with, I'm gonna start out with the low velocity, and then I'm gonna pick up. So the quick time I'm talking about is while I am speeding up. So, what was my velocity during that whole stint?
Negative.
What was my acceleration?
Positive.
Well, at least you accept it's not zero. So it is either positive or negative. Make an argument for positive.
You're speeding up.
And?
You get faster. You get faster.
No, that's true. I think by definition is speeding up. What's the argument for negative?
Because you're, relative to both the starting point and the origin, you're in the negative direction, left, so your acceleration would be negative.
It sounded like you were making an argument for velocity being negative.
Oh.
You also slowed down at the end though. So-
Well, just the part where I was speeding up.
Okay.
Yeah, and then I started walking back this way, so there's a whole jumble in there. I figured at this point, you're not ready to answer within, a 30th of a second.
But if you're talking about acceleration is velocity over time.
Change
so
in velocity.
Change in velocity over time. So if it was going negative the whole time
Right.
over that period of time, then the time is gonna be positive. So a negative
I hope so.
divided by a positive is still gonna be negative. So your acceleration would be negative.
But it's the change. If I go from -1,
Just gonna get a darker marker here.
if I go from -1 to 0, is that a positive change or a negative change?
That's positive.
If I go from -1 to -5, is that a positive change or a negative change? Negative. All right, so if I go from -1 meters per second to stopping, my acceleration,
Positive change.
it is positive. If I go from -1 meter per second to -5 meters per second, what's my acceleration?
Negative.
It is indeed. So just saying that speeding up, slowing down does not tell you anything about whether it's positive or acceleration is positive or negative.
So it was negative.
It was negative. Because I went from a negative velocity to a greater negative velocity. Although potentially misleading that wording, to a more negative velocity. So, in that case right there, if I sped up in the direction I was going in, it becomes a greater magnitude. So I went from -1 to -5. If I were in the positive direction and speeding up, I'd go from, say, 5 meters per second to 10 meters per second. I'm just gonna live in the fantasy that I can actually run at 10 meters per second, but hey, it's theoretical, of course I can. Not until someone times me. So, it turns out that if I'm speeding up, acceleration and velocity are the same sign. If I'm slowing down, so I want to take a wild shot at that one.
They're the opposite.
I assume that's exactly what you're about to say?
Of course.
Yeah. Acceleration, velocity, opposite sides.
Whoa. What did you just draw there?
That was an attempt to sort of capture that without having to rewrite the whole thing. It's horns. All right, so I start out moving to the left, my velocity is, let's try that one again. Caught you off guard. I'm walking to my right, your left. My velocity is,
Negative.
if I come to a stop, my acceleration is,
Positive.
as I come to a stop, my acceleration is positive. I slow down. If velocity is negative and I'm slowing down, acceleration has to be the opposite sign. I'm now moving to the right, my velocity is,
Positive.
as I stop,
Negative.
answering the question I didn't ask, what is the acceleration in t? If I walk at a constant velocity to the left, my acceleration,
Zero.
I think somebody just said it.
Zero.
Yes. All right. Questions before I make it potentially clearer or more confusing? Let's go for it then. Yeah, one of those things where it would be great to be able to teach chapters 2 and 4 simultaneously. However, not easy to do. So I'm going to sort of jump ahead just briefly and introduce this idea of a force. And that it turns out that the total force, generally you just write F, but the implication is the total force on an object is equal to the mass of the object times the acceleration of the object. Mathematically, I'm looking at this equation, I got two vectors. I know I have two vectors because one, I've done this before, and two, I got the vector symbols. Because I have only two vectors on each side of the equation, they have to be the same direction. Mathematically, there's no other way of doing it. The force and the acceleration have to be in the same direction. So if you think about a force just being a push, if I'm walking to the left and I get pushed in that direction, I'm being pushed in which direction?
The left.
Positive, negative, zero.
Negative.
All right. Therefore, my acceleration is negative. If I'm walking to the left, to your left, and someone pushes me in that direction, am I going to speed up or slow down?
Speed up.
So if I'm pushed in that direction, my acceleration, that will be negative, that will be negative, and it works out because my velocity and acceleration are both negative, I will speed up. If I'm walking in that direction and I'm pushed opposite the way I'm going, so I'm going this way, I'm being pushed that way,
You're gonna be slowed down.
absolutely. And in that case, I'm going to the left, my velocity is negative, acceleration will be positive.
That way, you know, opposite sides, then they're slowed down.
It all fits together. All right. Here we go. Velocity. Wow. Here we go. The velocity,
Negative.
I come to a stop.
Positive.
Acceleration is,
Positive.
I'm going to the left. I turn around. At that moment that I turn around, what is my acceleration?
Positive.
Zero? Because you stopped? Well, do you stop for a second and go, or do you just continue and keep going?
All right, let's think about the stop and acceleration being zero. Acceleration deals with change in velocity. If I stop and acceleration is zero, that means my velocity won't change. What's going to happen to me if I stop and my acceleration is zero?
Explode.
I hope not.
Zero. It'd be positive. It'd be like you just go the other way.
If I stop and my acceleration is zero, if my acceleration is zero, my velocity doesn't change.
If your acceleration is zero, oh no, then you're keeping on going. If
You missed the part that I stopped.
Oh.
If I stop, what's my velocity? If my acceleration is also zero, what will be my velocity a moment later?
Zero.
Yeah. So if I stop and acceleration is automatically zero, that means I'm not moving again. So there's a disconnect between acceleration and velocity, that if I know what the velocity is, that tells me nothing about acceleration. If I know what the acceleration is, all I know is what the change in velocity is gonna be. I don't know if the velocity is positive, negative, if I'm speeding up, slowing down, stopping. It doesn't tell me any of that information. Questions are here before we make it look more complicated. I see the look of excitement. The ground. I'm gonna make this my origin. I'm standing here. Every time I do this, I think I have a second or third cousin, Andy, who was born with his arm basically here. Think about that when I draw this. Actually, there was one particular time, so he was born obviously with most of his arm missing, and at one point he was young enough, he was sort of sucking on the end of his arm, and they were in a department store, and this kindly older woman said, "Better be careful, or you might swallow your hand." At which point he pops the nub out, and his hand is missing. The parents then explained. All right, so he's going to throw this object into the air. Into the air, it's going to come up and then come back down. If you need a visualization, sometimes physics demonstrations work. All right, so A is a time ball has just